Section 4.12, non-equilibrium application of Newton's laws of motion. So when an object is accelerating, it is not in equilibrium. This is the opposite of the last section, but it's going to be a very similar method. What we'll just see is that the sum of the forces in the x direction and the sum of the forces in the y direction are no longer going to be equal to 0. They're going to once again follow the full Newton's second law, equal to the mass times the acceleration in that particular direction. So these are two very powerful equations. This is the more general form of the last section, where in the last section, if you took these general Newton's second law equations and then said, hey, the acceleration is 0, you can simplify them. But this is the key equation, F equals ma, that we will keep coming back to again and again and again. So definitely want to pay attention to this, remember this, be totally clear and comfortable with it. So when you're solving this type of problem, how do you approach it? Well, we're going to modify our reasoning strategy just a bit. We're going to select an object, or objects, could be multiple ones, like last time we looked at both the foot as well as the 2.2 kilogram counterweight that was pulling and creating the tension, to which the new equations in Newton's second law in x and y components are to be applied. And here we have Newton's second law in x and y components. The sum of the forces, or the net force in the x direction, is equal to the mass times the acceleration in the x direction. The net force in the y direction is equal to the mass times the acceleration in the y direction. Then we're going to draw a free body diagram for each of the objects chosen above, including only forces acting on the object, not forces the object exerts on its environment. Choose a set of x and y axes for each object. Note, it doesn't have to be the same for both objects. In a moment, we're going to see another example where we have two different axes depending on the object. So we're then going to need to resolve all the forces in the free body diagram into components that point along these axes. Once you go through these 3 setup steps, which are a bit involved and a bit challenging, but if you can set it up just right, then step 4, you're just applying the equations and solving for unknown quantities. So the better your setup is, the better time you'll have in solving the problem. Once you have a good setup, the equations fall out of that, and then it becomes an algebra problem, which can still be a bit involved, but is no longer the same conceptual thinking that is required of physics. So the setup here is so key. The very last video is going to take a look at an example of a non-equilibrium application of Newton's laws of motion. It's going to pull together everything we've seen in this chapter. So stick around, you're not going to want to miss it.